So let us start. Meanwhile, others will also join, I hope. So this is first we are going to do variable separable method. So variable separable method, as you have also studied in the CBSE class, there we try to separate the variable. Like the variable of x will be with dx and variable of y will be with dy. So if you want to see this question here, in this question, there is y square root of 1 minus x square dy plus x square root of 1 minus y square dx is equal to 0. So in this question, if we try to find the solution of this differential equation, so we will have to separate the variables. So like here, root over 1 minus x square is getting multiplied with dy. Y is fine, that is okay. And in another one, root over 1 minus y square is getting multiplied with dx. X is fine. So we will do one thing. We will divide both sides by square root of 1 minus x square into square root of 1 minus y square. So when we will do this, this would become root over 1 minus x square will cancel and it will be y by square root of 1 minus y square dy, because we are dividing by square root of 1 minus x square into square root of 1 minus y square. So square root of 1 minus x square is getting cancelled. In another one, square root of 1 minus y square is getting cancelled and square root of 1 minus x square will remain. Dx equal to 0. Now if you integrate both sides, then we integrate. Right side will be 0 because if you divide 0 by anything, it will be 0. So integral of y root over 1 minus y square dy plus integral of x by root over 1 minus x square dx equal to 0. So just uh, find the integral of these two now because they are variables separable. Y, the function of y is with dy, the function of x with dx. X is not getting multiplied with y and y is not getting multiplied with dx. So it is now variable separable. Now you can integrate it. So by normal integration techniques, you just give it a try. So what we get after integrating this, as you know, that here substitution will work. Like if you take 1 minus y square as u, then minus 2y dy will be equal to du. Similarly, if you take 1 minus x square as v, then minus 2x dx will be equal to dv. So root over 1 minus y square is root over u, and y dy is actually du by minus 2. Similarly here, root over 1 minus x square is root over v, and x dx is minus half dv. This is equal to 0. So we have let this, and also we have let this. Now, if you take it as minus half u to the power minus 1 by 2 du, and minus half v to the power minus 1 by 2 dv equal to 0, you will get the integration as u to the power 1 by 2 into 2 it will become, because by half it will be, that is into 2, minus half v to the power 1 by 2 into 2 is equal to 0. And these two will get cancelled. Now you can substitute u and v and get the final answer. So if we substitute u as 1 minus y square, this minus sign will come as common. Root over 1 minus y square plus root over 1 minus x square is equal to 0. Minus will come outside and it will become go on the right side, and it will be get absorbed with 0. So plus c you have to do one more thing, because after integration we get a constant of integration also. So you either put it on the right side or put it on the left side, wherever you want. So root over 1 minus x square plus root over 1 minus y square equal to c. So the option is option, third option. This third option is the correct option, right? Let us come to the next question. This is also on variable separable method. So here it is not so difficult to separate the variable. You can easily see how you can separate them. So Sharif, you got disconnected. So let us complete this question, then we'll come to the next question. Fazil has also got disconnected. Let us see when Fazil will rejoin. Maybe some network issue. So dy by dx is equal to 1 plus y square into x. So we can say that dy by 1 plus y square is equal to x dx. Then we integrate both the sides. After integrating both the sides, dy by 1 plus y square is equal to tan inverse y. And x dx is x square by 2 plus c. So this is what you will get. Or you can change from tan inverse to tan. And you can say that tan of x square by 2 plus c is equal to y. So your option is option number 4. So when you remove tan inverse from here, on the right hand side, it will become tan. So the fourth option is the correct option. Now let us come to the next question. You just write this solution, then we'll see the next question. This is the third question. Shabaz, you joined little late. We have started differential equation using variable separable method. This is the third question. Here exactly it will not be variable separable. You have to think little bit beyond that also. Like if you try to separate the variables, what will happen is that dx is of course there, minus x dy is there, and then minus y dy is there, and then minus dy equal to 0. Now, if you want to separate x with dx, y with dy, so what will be the problem is that this x dy is creating some problem. Because if you divide by x, then what will happen? It will be dx by dx minus dy. Till here it is fine. But here it will x which is coming, and here also x it is coming. So these two will become now the problem. So if you divide by x, so that x comes with dx and get rid of dy, so next third and fourth term will be the problem. So we can't do in either of these ways. So what we have to do here is, we'll take it as a dx is equal to x plus y plus 1 dy. So dy by dx is equal to 1 by x plus y plus 1. This is what we are getting here. Now, after writing this, what you need to do is to do a substitution. And that substitution is that you will take let x plus y plus 1 is equal to t. So what will happen? 1 plus dy by dx, and the derivative of 1 will be 0. That will be 0, is equal to dt by dx. So 1 dy by dx can be written as dt by dx minus 1. So this is what you have to do here. So therefore, first you write it like this. And then this is the important substitution which you have to do. From here, you can find dy by dx as dt by dx minus 1. And just put it in the first equation and see how it can be solved now. Should I tell you or you are getting the result?
Sir, I'm getting this.
Okay. So it is taking some time,
You can
Shabaz.
say the answer.
Sorry, should I tell?
Sir, is it option 3?
Option 3, 1 second. Yeah, correct. Option 3. Yes. So basically, when you will do the substitution, what will happen? That this first equation will become dt by dx minus 1 is equal to 1 by t. So this will become dt by dx is equal to 1 by t plus 1, which means it will be dt by dx is equal to 1 plus t by t. So this is what we will get. Now we can separate the variable and it is not so difficult. So we will write t by 1 plus t cross multiply dt and we will cross multiply dx. Integrate both the sides. Here we will write it as t plus 1 minus 1. So it will be easier to integrate. Here it will be x plus c. This will become t plus 1 by t plus 1. That will be 1. So dt only. Minus 1 by t plus 1. Dt is another term equal to x plus c. Now integral of dt is t. Integral of 1 by t plus 1 is log of mod of t plus 1 is equal to x plus c. So what we are getting is log of mod of t plus 1 is equal to t minus x plus c. So log of mod of t we are taking as you can see here, t we are taking as x plus y plus 1. So this will be x plus y plus 1 is equal to, this will become y plus 1 because x will get cancelled plus c. So the final result will be, if you remove log, so it will become x plus y plus 1 is equal to e to the power y plus 1 plus c. So it will become, yeah, it is plus 2 coming. Plus 2, how it is coming plus 2? Okay, t is x plus y plus 1, na? So plus 1 is already there. So plus 1 and plus 1, it will become plus 2. So this, when you will substitute this t here, so when you will substitute this t, it is x plus y plus 1. So this will become, t plus 1 will become x plus y plus 2. So this will be x plus y plus 2. So this will become x plus y plus 2 is equal to e to the power y into e to the power 1 plus c. And this will become x plus y plus 2 into e to the power minus y. When you will take that e to the power y on the left hand side, it will become e to the power minus y. And this e to the power 1 plus c is a constant, which is c. So therefore, we get this result. X plus y plus 2 into e to the power minus y equal to c. So x plus y plus 2 into e to the power minus y equal to c, which is the third option we have. So Shabazz has done it. Sharif, you can write it down, and if you have doubt in any step, you can just ask it. From here, you have written it, no? Yeah, from here you have to write. So I hope you have written till here. Now you can write this much. And we'll come to the next question now. This is the next question. It is also variable
Yes, sir.
separable. Yeah. So this is also variable separable, but you have to little
So
cautious
like
here.
this was really variable separable or this was homogeneous.
No, this is variable separable, but it is not exactly variable separable because you can't separate x and y. So you have to, this type of differential equations are also called exact differential equations, where you have to analyze that what combination you have to make in order to solve it. That was variable separable after reducing. That if you talk about question number 3, it was reducible to variable separable. It was after the doing substitution, it became variable separable. Now next one which I'm giving, it will become variable separable, but after you have to find it out that what is the combination which you have to make, because x and y cannot be separated. So you have to make a proper combination. Like I can give you a hint that this function, if you will write as y e to the power xy dx, and then plus x e to the power xy dy plus 2y dy equal to 0. And then you take e to the power xy common. So it will be y dx plus x dy plus 2y dy equal to 0. Now you have to think a little bit what you need to do. So two steps I have given. First, I opened the bracket and then I have mixed, taken e to the power xy common. So should I give a hint?
Yes.
So what you do here is this y dx into x dy can be written as d of x into y. Because when you do d of x into y by product rule, first function into derivative of second plus second function into derivative of first. This is all you can write. So this is now you have to do. Now the work is not so difficult. Now you take xy as t here in the first one. So it is e to the power dt. And don't take anything here. So let t is equal to xy. And then you integrate both the sides by they are already variable separable. T term with dt, x, y term with y. Do the integration and finally put t as xy. Have you got the answer?
Yes, sir.
No. So now it is not
Should I
so.
tell the answer?
Sorry,
Should I tell the answer, sir?
I couldn't understand you, Shabazz, what you are saying.
Can I tell the answer, sir?
Yeah, I'm just telling the answer. So it will be e to the power t plus y square equal to is equal to constant. After integration, there is a constant of integration. And then we have t is equal to xy. So e to the power xy plus y square is equal to c. So the option is the option number 4. Now you can try one more question. This is the last question of the day. I think this is the 5th question. Here it is directly variable separable. You don't have to do much. Is it done, Sure. Should we discuss or you are trying it? Sharif, what about you? Have you done it?
No, sir.
So here there is only little mix of functions are there, but it is not so difficult. So if you see dy by dx is equal to this right hand side power is -1. So that will just make it reciprocal. E to the power x tan y by e to the power x -1 sec square y. Now separate the variables. So dy will be multiplied with sec square y and divide by tan y, and e to the power x by e to the power x -1 dx, cross multiply, and we integrate them. So if you take tan y as a function u, sec square y dy will be du. If you let u is equal to tan y, then du will be sec square y dy. And another one is e to the power x by e to the power x -1. So here also you can do one thing. You can take e to the power x -1 as some other variable t. So on differentiating, dt will be equal to e to the power x dx. So it will be dt by t. So when you integrate, du by u integral is log u, dt by t integral is log t plus c. So it will be log of u by t is equal to c when you will take on the left side. So u by t is equal to e to the power c, which is also a constant k, let us suppose, or you can say that as c also. There is not an issue. So when you will write the final answer, u is equal to tan y and you cross multiply t. So that is k into e to the power x -1. So this will be the answer which you will get. Tan y is equal to k into e to the power x -1. That is option 1. If you see here, you take 1 on the left, e to the power x -1 is equal to c tan y. And you can also write it as 1 by c, which is another constant k, e to the power x -1 is equal to tan y. So tan y is equal to k e to the power x -1. You can say this.